Hi, I'm Kian, and today I want to show you how to solve this question. This is a question recommended by math expert and teacher Mehdi Fati. So let's dig into it. So we have a function f of x, which is sine of 5x plus pi over 4, and we have p of x, which is another function, and this is a third degree Taylor polynomial for f at 0. We need to find p of x. So for Taylor polynomials, always first make a table. How? So I'm gonna make a table and show you step by step how to solve this question, because these questions come sometimes in many calculus exams, such as AP Calculus. So here we create a table, and we make one because we need the third degree. So we need one. This is a 0. This is 1. This is second degree, and this is a third degree polynomial, and we call this n, which is like the number of degrees. We call this the nth derivative of f evaluated at x, which in this case we know that x is 0. And then, of course, the formula for Taylor polynomials, which is the nth derivative of f evaluated at x divided by n factorial, which in this case we can simplify it to the nth derivative of f evaluated at 0 and then divided by n factorial. Okay, so first of all, we know that the zeroth derivative, because now, first of all, when n is equal to 0, the zeroth derivative of any function is just the original function. So for the first row, we just need to plug in the original function, which is sine of 5x plus pi over 4. Sine of 5x plus pi over 4. Now, for the second row, we need the first derivative because n is 1, so we need the first derivative of f. So we know that the derivative of sine is just cosine, and the inside remains the same, but we need to apply the chain rule. We need to multiply by the derivative of inside. So for the final, we get just 5 times cosine of 5x plus pi over 4. So we get 5 times sine of 5x plus pi over 4. And now we need to find the second derivative. So for finding the second derivative, when n is equal to 2, we need to just differentiate 5 times sine of, and this should be cosine. I'm sorry, I made a small mistake. This should be cosine because the derivative of sine is actually cosine. So I made a small mistake here. I'm sorry. So now we should differentiate 5 times cosine of 5x plus pi over 4. And now again, we should apply the chain rule. So we know that the derivative of cosine is negative sine. So when we multiply by 5, we get negative 25 sine of pi x, 5x, sorry, pi x, not pi x, 5x plus pi over 4. So for the second derivative of our function, we get negative, and then 25, we apply the chain rule. We multiply by the derivative inside. We get 25, and then sine of, and the inside just remains the same. 5x plus pi over 4. And now we want to find the third derivative of our function. So again, we should differentiate this part, a negative 25 sine of pi x plus pi over 4. When we want to differentiate it, again, we should use a chain rule. We should multiply the 5 out of, but we know that the derivative of negative sine is negative cosine. So we know that this is just negative cosine of 5x plus pi over 4, but we need to apply the chain rule, multiply it by 5. So we get actually negative 125 cosine of 5x plus pi over 4. I need a little space, so write it here. 125, and then cosine of 5x plus pi over 4. Pi over 4. Okay, now for the third row, we should evaluate this. Evaluate the derivatives, the nth derivatives at 0, and then divide by n factorial. So for the first one, for example, when we plug in x is equal to 0, we get sine of pi over 4, which we know is square root of 2 over 2, and then divided by n factorial. 0 factorial is 1. So let me extend this. So for the first row, we just get, I write it here, square root of 2 over 2 over 0 factorial, which is just square root of 2 over 2. For the second row, when we plug in 0, again, cosine of pi over 4 is square root of 2 over 2 times 5, and then divided by 1 factorial, we get 5 square root of 2 over 2. So we get 5. Let me write it a little smaller. 5 square root of 2 over 2. For the third row, actually, we get, when we plug in 0, we get sine of pi over 4, again is square root of 2 over 2, times negative 25. So here, actually, we get negative 25, and then square root of 2. And then because we're dividing by 2 factorial, we can put this 2 factorial, which is again 2, and then multiply it by a 2, which comes from the square root of 2 over 2. So it's negative 25 square root of 2 over 2, and then divided by 2 factorial, which will be the same when we simplify it. And now for the fourth row, we need to put 0. We get cosine of pi over 4, square root of 2 over 2, times negative 125. We just get, and then divided by 3 factorial. I'm going to putting it here. We get negative 125 times the square root of 2, and then over 3 factorial, which is 6 multiplied by 2. Okay, now we're done with most of the steps, and now we want to finalize our final answer. So let me use a different color. So now we know that p of x, so now we have found all the coefficients up to the third degree Taylor polynomial. Now we should just multiply by x to the power of n. So the actual formula is the nth derivative of f evaluated at x, which in this case is 0, over n factorial, and then times x to the power of n. So in this case, our first coefficient is square root of 2 over 2. So we get just square root of 2 over 2 times x to the 0, which is 1. And then minus, and then actually plus, because the second one's also positive, plus 5 times square root of 2, and then over 2, but we need to multiply it by x to the power of n, which in this case n is 1, so we should multiply it by x. And the next one is negative, so we should subtract 25 times square root of 2, and then all over, and then 2 times 2 we know that is 4 times, and then multiplied by x to the second power. And now lastly, for the third degree Taylor polynomial, for the third degree, we should again subtract by 125, and then square root of 2, and then all over. 6 times 2 is 12 times x to the power of n, which is x cubed. And we are done. Thanks for watching. Please subscribe to my channel, and thanks to Mehdi